guys, hi, hello everyone. A very warm welcome to your today's chemistry session in which we gonna revise the entire chapter study of compounds ammonia in one shot. So this session is going to be super helpful for you. Do not miss on at any part of the video and subscribe to the channel if in case you haven't, so that you do not miss on any of the videos that we would be coming up with. So you would be actively staying on the channel so that you can practice lot of questions and the content that's gonna help you for term 2 exam. Okay, and if in case you are looking forward to take the Vedantu Pro subscription for ICSE for any of the subject you feel like, ma'am, I am having hard time doing science, maths, then I need some real time help, don't worry, Vedantu is here, and for every time 10% discount you can use Shilpi Mam's coupon code, that is Shilpi Kaushik Army Pro. SKA Pro is a coupon code that's gonna help you. So let's start the chapter study of compounds ammonia. So this is the only basic gas that is present in your syllabus. Okay, it's a basic gas and you can see a structure that is shown over here in the form of pyramidal shape, something like that. That is the shape of ammonia. Let's discuss the molecular formula is NH3. If you calculate the relative molecular mass, that's going to be ammonia is having nitrogen. So one nitrogen atom has a relative atomic mass of 14 and 3 hydrogen. One hydrogen has a relative atomic mass of 1. So 3 के लिए it is 3 है ना. So 14 plus 3 that is equal to 17 atomic mass unit. The relative molecular mass. The relative molecular mass for ammonia comes out to be 17, and the type of bonds that are present in it are single covalent bonds. Okay, we can draw it also. यहाँ पर ही देख लो. You see the nitrogen is having a configuration of 2,5. So nitrogen is having how many valence electrons? 5 valence electrons, and hydrogen has a configuration of 1. Only 1 electron is there. So in ammonia, nitrogen requires 3 more electron to complete the octet. So it's gonna share 1 electron each with the hydrogen atom like this. Okay, that's a bit untidy. So you can manage it, and nitrogen is having a complete octet here. So each hydrogen atom is getting a duplet. Okay, and the nitrogen atom also got an octet. So that is how ammonia looks like now. This is nitrogen and the single covalent bonds, 3 with each hydrogen, and this is the valence electron which is not participating in bond formation, and we call it as a lone pair, right? So those valence electrons which are not participating in bond formation, they are lone pair. We have already done them. Lone means akela pair of electrons here. Okay, so this is having a pyramidal shape, pyramidal. Okay, you can see over here they have shown it here. So there are 3 single covalent bonds, and in the free state it can be found in very small amount in the air and traces in the natural water also. Apart from that, combined state mein lot of compounds are known. Ammonium fluoride is a very famous salt that you have seen already at a lot of places. Acid bases maybe we have done. It is what kind of salt? Acidic salt, which is coming from a weak base and a strong acid, and so that is the acidic salt. And ammonium sulfate you have seen, right? So they are the combined state, and ammonia and ammonium compounds are highly soluble in water. So they do not occur in the form of minerals because water soluble hote hain. Minerals mein mainly you are having the solid O's that are existing over there. So not ammonium compounds. They won't be existing as the minerals. Okay, and one more thing guys, I will tell you, if you have been to public places, या आपने देखा होगा ना, like there are a lot of people, they don't prefer to use the public place वाले washrooms because they're not very much you can say clean, and वहाँ पर there's always a very bad odor that keeps on coming. That is also because of ammonia, because urine is having urea in it. Okay, urea, you have seen the first organic compound which was synthesized in chemistry lab, NH2CONH2, and in the presence of bacterial decomposition, पानी भी होता है वहाँ पर, है ना, in the presence of water, bacteria are gonna decompose it and leads to the formation of your ammonia. That's like yuck ma'am, what is that smell, है ना, वो इसी की वजह से आती है ammonia smell. That's pungent smell is present, and this is the reaction that takes place over there. Urea in the presence of water, because of bacterial decomposition, gives rise to ammonia gas with a pungent smell. Apart from that, CO2 and water is also released over there. So now we would be talking about the different forms of ammonia in which it can exist. The first is gaseous ammonia. बहुत simple है. This is like the dry ammonia gas that we usually talk about. Okay, and apart from that, liquid ammonia is there. Now liquid ammonia is nothing but when dry ammonia gas is applied, you know, under high pressure, we convert it into the liquid form. So yeah, under high pressure it is converted to liquid state, है ना, that is available in the cylinders. Now the third form is liquor ammonia fortis. Now this is different from liquid ammonia. Liquor ammonia fortis is a saturated solution of ammonia in water. Okay, so it's the saturated solution and काफी concentrated होता है. It's around like you can say 33% concentrated, and it is also known as 880 ammonia. 880 here indicates the relative density, मतलब it's so lighter than air. We compare, that is what we are comparing over here. Okay, and this is stored in this tightly stoppered bottles in the cool places also, so you don't have to take a very high temperature. Okay, just the normal cold place is fine. And the fourth one is laboratory bench reagent. That is simply that you've seen in chemistry labs also, you know, kept over the benches. That is the dilute solution of the liquor ammonia. So because liquor ammonia is quite concentrated, this is like the dilute one, right? Apart from that, what would be the general methods of preparation? Usually ammonia आपको मिलती है when you are having ammonium salts and they undergo decomposition, you can say. Okay, so most of the ammonium salts on heating are going to release ammonia. But do we have an exception? So questions like this are asked in the exam, कि you have to mention those ammonium salts which cannot give ammonia on heating, है ना. So like my video is visible, so ammonium nitrite, nitrate, you can say यहाँ पर. If in case you take the ammonium nitrate also, this is explosive in nature. Okay, so you have to avoid it, and even on decomposition it is not gonna give ammonia, rather it will give oxides of nitrogen, right? The same happens with the ammonium nitrite also. If you take this, then you are gonna heat it. On heating it will not be releasing ammonia, rather nitrogen and water. So we have to avoid these two ammonium salts. So exam mein kabhi aaye, you have to be prepared with that. Okay, so that can be asked. Exceptions are always the most important thing in chemistry, and you guys already know that. So apart from that, what we have to take, see, I'm taking ammonium chloride plus I've taken a base. Okay, like slaked lime I have taken, or you can also take caustic soda, caustic potash, that is like NaOH, KOH, but they are avoided. ठीक है, सोडियम हाइड्रोक्साइड, पोटेशियम हाइड्रोक्साइड, we try to avoid them because they have a tendency of absorbing moisture from the air and dissolve in it. Okay, they might absorb moisture from the air, okay, and dissolve, deliquescent होते हैं. Okay, so just remember that we can just avoid it because they are deliquescent in nature. So you can go with calcium hydroxide, otherwise like to sometimes you can take them also, but not much favorable. Okay, so this is a kind of double displacement reaction where ammonium ions are combining with OH ions and calcium with chloride. ठीक है, calcium ions go with chloride ions, give you a salt calcium chloride, and ammonium ion OH ions give you ammonium hydroxide. That is again not very much stable, so it decomposes to give us water and ammonia. Okay, so what do you get? Ammonia gas is released into the surroundings. This is how we can prepare ammonia gas. So have a look at it, how we will do it in a chemistry lab, laboratory preparation mein. So reactants we are taking is ammonium chloride and calcium hydroxide in a ratio 2 is to 3 by weight. Why are we taking this ratio? Because ammonium chloride is a sublimable solid. Beta, kaisa solid hai? This is a sublimable solid. So with the passage of time, you know that this solid will be converted into vapor. So quantity will be decreased. So if quantity of one of the reactants is decreasing, the rate of reaction would be impacted. The rate of reaction is going to decrease. So we have to take, what do? हम calcium hydroxide को बढ़ा देते हैं. We take it in the more quantity. Okay, so this is taken in 3 ratio and ammonium chloride in 2. So you will say, ma'am, why are we not increasing the ratio of ammonium chloride when it is getting sublimed? You know, there can be a question why we are not taking 3:2 ka ratio. Because if ammonium chloride is getting sublimed, then we should take it in a high quantity. But this is relatively expensive. Okay, calcium hydroxide is still cheap, easily available. So we take the more ratio of calcium hydroxide. So even if one of the reactant you are increasing in quantity, the rate of reaction will be increased. Okay, so just to favor the reaction ka rate, we do this. So we are taking a ratio. So again, what products we would be getting? Salt, apart from that water and ammonia. So have a look at the diagram, like the setup, experimental setup shown over here. What we are taking the reactants ammonium chloride and calcium hydroxide over here. Okay, now what happens, you can see we have taken a tilted flask. Why would we even do this? Because देखो आपको water vapors मिल रहे हैं, है ना? So what will happen over here? Calcium chloride is still deposited at the bottom, solid है. We are having water vapors and ammonia that is in the form of gas type of thing. So water vapors, they can, you know, condense back in the flask. Now they are vapors, they can condense back and fall into the flask, so it can break. So what can happen? We are taking in a tilted way so that we can avoid the breakage of the flask. To avoid the breakage of the flask from the condensed water vapors that would be very much hot as soon as they fall over the surface of the flask. Okay, so what happens? We take it in a tilted way ताकि the ammonia and water vapors, they just directly pass through this. Okay, the mouth of the conical flask. So what happens? Ammonia gas and water vapors are passing and passing and passing. They reach over here. Now what is this? We are keeping calcium oxide over here that acts as a drying agent. So what calcium oxide is doing? Whatever would be the water, that would be absorbed by calcium oxide. है ना? It is absorbing the water vapors so that we are just left behind with ammonia over here. So यहाँ पर जाकर we can collect the ammonia. Right, so it's written here, in order to get dry ammonia, the gases pass through a drying tower containing the lumps of quicklime. ये रहा. Okay, so this is the drying tower that we are basically mentioning over here. Easy है, not difficult. We can do this. I guess everything is clear till here. Okay, very good. So continuing over here. The next thing that you can see, how are we going to collect this ammonia? यहाँ से how we will collect ammonia. Okay, so the method that we use for collection of the ammonia is the downward displacement of air. So जैसे ammonia is going into this vessel, it would be displacing all the air like this. Air goes out and ammonia would be collected over here. So we are getting it by downward displacement of air. What could be the reason? Because it is lighter than air. Okay, so if you can compare, the vapor density of ammonia is 8.5, but that of air is 14.4. There's a huge difference. So lighter than air, it will go and would be just displacing air. Okay, so downward displacement we do, and we cannot even collect it over water. The reason is that it is extremely soluble in water, almost like you can say 1:700 parts. Okay, बहुत high solubility है. So because of that, we are not going to collect it over the water. Okay, the next method of preparation is from the metal nitrides. Now this method is not very much favored because they are quite costly. Action of water on nitrides. Nitrides, you understand, N3 negative, है ना? So what do? Nitrides we're gonna take n raised to power like 3 negative charge. So remember, don't get confused in nitrite, nitrate or nitrite. So when the suffix is "ite", then only non-metal is present without oxygen, okay, having a charge of 3 negative. So how do we make ammonia by this method? We have to take a metal nitride, treat it with water, okay. So again, so what is happening, you can easily make the reaction by breaking the reactants ke atoms. So magnesium, take the 2 OH ions over here, make magnesium hydroxide, and apart from that we would be getting ammonia gas. That is what we wanted. So I'm covering the setup over here, you can see this, okay. So see, magnesium nitride we have taken over here, plus ऊपर से we are adding the warm water. So what will happen when they are being mixed, we would be getting magnesium hydroxide over here, ठीक है. यहाँ से देखो, magnesium hydroxide would be settled over here, and the ammonia gas that is formed would be passed from here, okay. So ammonia gas, if there is any water vapor presence, that would be absorbed over here in the drying agent, and then again यहाँ पर we would be getting the ammonia gas, okay. So you can see ammonia gas is liberated, magnesium hydroxide is also formed, but it remains in the flask. So liberated ammonia gas escaped through the delivery tube over here, then you pass the drying agent. One more question I am having for you, can we use some another drying agent? Why are we taking calcium oxide as a drying agent? This question can be asked in your exam. So these chotu se questions, you should be clear about them. Conceptual question ki ma'am, why are we taking it, why not that? So that should be clear. Why don't we go with simply, you can say, sulfuric acid. Conc sulfuric acid can also act as a drying agent. You can go with the phosphorus pentoxide, you can go with anhydrous calcium chloride. Why they are not taken over here? The reason is that ammonia is a basic gas, and calcium oxide, ammonia is a basic gas, metal oxides are basic in nature. There won't be any reaction that calcium oxide would be showing with ammonia. But if I talk about concentrated sulfuric acid with ammonia, acid with a base, there would be a reaction, okay. So reaction ho jayega. So we have to avoid sulfuric acid as a drying agent. We cannot go with phosphorus pentoxide. यहाँ पर भी it will be reacting with ammonia. Anhydrous calcium chloride will react with ammonia, okay. So you have to avoid that drying agent. So safely we go with the calcium oxide. Are we clear on this? Okay, ठीक है. चलो, the next one is preparation of aqueous ammonia. Aqueous ammonia बनाना बहुत आसान है. What you have to do? You take ammonia gas, dissolve it in water. Okay, preparation of ammonia gas से now we are done with that. We are preparing aqueous form. Ammonia को water में डाल दो. Okay, so what you would be getting? Think about it. Aqueous solution of ammonia is prepared by dissolving ammonia in water. Ammonium hydroxide आपको मिलता है ना? So ammonium hydroxide, what kind of bond it is having? Can you tell me what kind of bond it is having? Ammonium hydroxide. Yes. Covalent ionic coordinate. Think about it. Tell me the answer in the comment section. The rate of dissolution of ammonia in water is very high, guys. This is something you have to pay attention to. Okay. So ammonium chloride and calcium hydroxide, like जो भी sources थे, we have taken the reactants basically, and यहाँ पर we are getting ammonia. ठीक है, यहाँ हमें अमोनिया मिला. नाउ अमोनिया इज हाईली सॉल्यूबल इन वाटर, सो व्हाट इट वुड डू, इट विल ट्राई टू सक वाटर. सो बैक सक्शन हो जाएगा यहाँ से बिकॉज ऑफ द प्रेशर दैट वुड बी क्रिएटेड. सो वाटर क्या होगा, इट माइट गो बैक. So there is a possibility of back suction. So इसीलिए in the advance we use a drying agent. ठीक है, before doing this we already use a drying agent so that the reaction setup is not disturbed over there. Okay, so that's easy. And remember this aqueous solution of ammonia कैसे prepare करोगे? Just by dissolving ammonia in the water. Okay, we can just make it, but we have to make sure कि there is a possibility back suction है ना. This is what we are trying to do. This is ammonia coming over here, this is water. So एकदम से back section हो सकता है. So we have to just be aware of that. Manufacture of ammonia by one of the most famous method, and that is Haber's process. Haber's process, I guess you all have done this. Yes or no? You know about Haber's process? Tell ma'am in the chat box. Yes ma'am, we are smart enough to do it. Everything is visible, there is no problem till here. Okay, ठीक है. So यहाँ पर देखो, नाइट्रोजन गैस एंड हाइड्रोजन गैस we would be taking in 1:3 ratio of volume. Why volume I'm saying? Because they are the gases. Okay, so 1:3 volume में we have to take them, then we would be getting 2 moles of ammonia, plus there would be heat released. So first of all, it's visible that this is an exothermic reaction. The heat is being released. The second point to look at is that there is a double-headed arrow, matlab there is an equilibrium in the reaction. Okay, so equilibrium hai, so iska matlab reaction is proceeding in forward as well as in the backward direction. Reactants to product as well as product to reactant side. Now the second thing is that you have to always make sure that reactants are very much pure in this method. ठीक है, and let me tell you that बहुत कम percentage is gonna react. 15% of the reacting gases get converted to ammonia. So the percentage in which you would be getting the conversion of reactant to product is very less, yet this is one of the most successful methods of making ammonia. There is something special about it. Okay, so yeah, we have to see the reaction reversible hai, exothermic hai, plus how this will be favored. We will see that. So guys, because heat is already being released in the reaction, so this is not favored at very high temperature. There should be an optimum temperature at which the reaction has to take place, because बहुत high temperature पे what will happen, reaction is already exothermic. Okay, and according to Le-Chat-Layer principle says that whenever a reaction is happening on equilibrium, then whatever change you are gonna doing on the reaction, then reaction will proceed in that direction so as to reverse that change. मतलब let's say if I am increasing very high temperature, बहुत high temperature मैंने लगाया, the reaction is already releasing heat on the the product side, so reaction would be favored on the reactant side, जहाँ पर where the heat is less, heat content is less. This is not just with the temperature, it happens with the pressure also. ठीक है, if I am applying high pressure condition on the equilibrium, reaction will shift on that side where there is less amount of pressure. Okay, जैसे this reaction is favored at the low volume also. ठीक है, there's a point कि why this reaction proceeds with decrease in the volume. So again we have to see the changes according to Le-Chat-Layer principle. So it's the simple thing कि reaction at equilibrium will proceed in that direction so as the change is reversed. Okay, be it temperature, pressure, volume, whatever it is. So anyway, the reaction is reversible, exothermic, and proceed with a decrease in volume. So how we gonna do this reaction? So ये भी देख सकते हो, why proceed with a decrease in volume? Because on the reactant side, total moles of gases are 4. 4 volume of gases there on the reactant side, and product side में there is only 2 volume. Okay, so where the reaction is gonna proceed? Tell me, think about it. Okay, यहाँ पर देखो, we have taken nitrogen and hydrogen gases. Okay, इसके बाद these gases are passing, they are mixing over there in a compressor where we are applying high pressure condition. Pressure of 200 atmosphere is being applied over here, but yet this is not enough to proceed the reaction. ठीक है, because reaction का rate would be very slow. So if we want to increase the speed of the reaction, we have to take some catalyst over here. So we do add iron oxide as a catalyst over here. Okay, then what happens? The speed of the reaction increases. Hydrogen would be reacting and will be giving us ammonia over here. This is a cooling chamber. जैसे ma'am told you, not all of the reactants are converted to the products. There would be a lot of unused amount of the reactants. So the unreacted nitrogen and hydrogen will go back from here. So there's a connecting pipe you can see, so that we are making use of the reactants, we are not wasting them. So unreacted nitrogen hydrogen goes here, again it comes in this chamber compressor, and once you are heating it, once you give temperature in the reaction, you don't need to heat it again, because the reaction is already releasing some heat. So that released heat is sufficient to take the reaction to a next level. Okay, so the unreacted nitrogen and hydrogen would be going back, and then ammonia gas is cooled to liquefy the gas. Cooling can be done, and this is a cooling chamber you can see over here, and we would be getting the liquid ammonia finally. So this is very important, it can be asked in exam, you have to be ready. Manufacture of ammonia by Haber's process, what are the favorable conditions? ठीक है, कैसे reaction favor होगा? The first is temperature. We cannot take low temperature because low temperature per rate of reaction would be less. We cannot take a very high temperature because reaction का direction will change. So optimum temperature we check experimentally is around 450 to 500 degrees Celsius to carry out the reaction. The pressure we take above 200 atmosphere around it. Catalyst is again used to increase the speed of the reaction, increase the rate of reaction over here. That is finally divided iron. Why finally divided? Because finally divided का मतलब है the surface area would be increased, which will help to increase the rate of the reaction. And we also take promoter in the reaction. Promoter will further help the catalyst to proceed the reaction at a higher rate, and that is molybdenum or aluminium oxide taken. Okay, chalo. Now the next thing, ammonia, how you will be separating it. How ammonia is separated from unreacted nitrogen and hydrogen? That would be done by liquefaction. Okay, liquefaction कर सकते हो. The reason is that ammonia is easily liquefiable as compared to nitrogen and hydrogen, because finally in the chamber you have unreacted nitrogen and hydrogen and ammonia also. So when you do the liquefaction, सबसे पहले the ammonia would be obtained, because that would be easily converted to the liquid सबसे fast. Okay. The next thing that we can do is to absorb it in water, because again ammonia is highly soluble in water, but nitrogen and hydrogen are slightly soluble. So it's the comparative basis that is helping us clearly, be it liquefaction or by using water in the obtaining the process. ठीक है, for the separation कुछ भी ले सकते हो. And again everything is written over here for your help. Why do we need catalyst and promoter? So that speed of the reaction can be improved. Okay, chalo. So promoter is increasing the efficiency of catalyst over here. So notes you can download and study from them. Okay, I guess that's clear. So guys, one more thing I would like to tell you about the Vedantu's courses. Like some of you are still not ready for your term 2. You would be having a confusion ki ma'am, we would be needing some help, and you know we are confused, how do we proceed with the preparation? So don't worry, because Vedantu is here for you. You would be able to enroll in Vedantu's crash courses. The new batch is starting just now, the coming week. So you still have 1 month to prepare very well. So subscription of 1 month would be like, you know, giving you everything, like be it the unlimited live classes. Yes, test series and analysis would be done for you. टेस्ट सीरीज आपको मिलेगा ताकि यू कैन compete with the students and know your rank accordingly. Where am I standing? What are the topics of area where I need improvement? Assignments and notes are given by Vedantu, because the more questions are very much important for us. The more questions we're gonna do, the better we would be becoming. So doubt solving during the classes. अगर doubts रह गए तो the concepts are not cleared. Okay, so even the doubt solving is there on the mobile app that is available in classic subscription. You can go with the light subscription. The prices shown over here is without a coupon code, but you have Shilpi Mam's coupon code, that is Shilpi Kaushik Army Pro. So you have to go to a link for the subscription that is given in description box of this video. वहाँ पर जाकर open the link, go to the class. Okay, simply you will choose your grade ICSE class 10th आपने choose किया, okay, you get extra 10% off over here. So for 1 month, for 15 days, it is written 1170 rupees for 15 days. But the moment you apply Shilpi Mam's coupon code, you will get 15 days free with it. Free. So that means for a total of 1 month, you are paying 1170 rupees for ICSE. That is completely worth it, guys. You should not be missing it. Okay, so jaldi si grab kar lo before the batches are completely filled. So you still have time. 7th February ko the last batch got started for CBSE. For ICSE ko 24 January ko, and the coming week a new batch is starting. Okay, new batch would be enrolled, like you will get the enrollment directly by your favorite master teachers. और क्या चाहिए life में, everything would be easy. Okay, so now let's talk about physical properties of ammonia. Ammonia is a colorless gas, and if you talk about the odor, that's I don't want to smell it. Pungent, choking smell. Taste is slightly bitter because it's a basic gas and bases are usually bitter to taste. And physiological action क्या होगा? Not poisonous as such, but if inhaled for longer period of time continuously, then it impact your respiratory system and it can bring tears to the eyes. Powerful heart stimulant, so यही होना चाहिए. You don't come in contact with it because large quantities inhalation can lead to death. Boiling point, it boils at around minus 33.5 degrees, and freezing point you can see 77.7. You don't need to learn the boiling and freezing points, just the basic properties we are seeing. Highly soluble in water, काफी ज़्यादा soluble है. Chemical properties of ammonia, thermal decomposition. Now ammonia gas, if you are just keeping it, then what will happen in the presence of heat? Therm means heat. So in the presence of heat, it will break down to give us nitrogen and hydrogen. Okay, at high temperature, or dissociation भी हो जाता है by the electric sparks in the presence of electricity. Okay, so it's just Haber's process में you have seen the reverse reaction. Hydrogen in the chamber were giving ammonia. Basic is happening. Okay, and it is also having basic properties. Have you heard about the name Lewis? Yes. So Lewis said that any substance which is an electron donor, that can act as a base. So how he defined bases? As electron donors. And if you see ammonia over here, dry ammonia is a covalent molecule. We have seen it. And nitrogen is having a lone pair of electron. Now this lone pair of electron is available for donation. Remember, ammonia combines with a proton to give you ammonium ion. There is a coordinate bond that is formed here. How that coordinate bond is being formed? Because ammonia donates its lone pair of electron to H plus ion and makes ammonium ion. So it has a basic 10 property, basic properties होती हैं. Okay, an aqueous solution of ammonia is a weak base. So I've told you, अभी किया था थोड़ी देर पहले the same reaction. The way you were making the aqueous solution of ammonia, you take ammonia, dissolve it in water, you do get ammonium hydroxide. Now that is a weak base. It can just dissociate easily to give OH ions, and these OH ions are less in number because it is a weak base, and weak bases are not completely dissociated, है ना? Partially dissociate होने वाला है, partially break down करेगा, partially dissociate to give OH ions, or less OH ions. And alkaline behavior is also because of these hydroxyl ions that it is giving. Okay, so let's continue to the second one property, that is the action on the indicator. So now we know that ammonia is a basic gas, so it would be showing the color changes like the normal bases do. So phenolphthalein in bases is gonna give us pink color. So yeah, when it comes in contact with it, we would be getting a pink color. You can remember it from the trick PBP. That's phenolphthalein in bases turns pink. The next is methyl orange. For methyl orange, you can remember the trick, apple is red in color. So in the acids, A for acid, we would be getting a red color. But because this is a basic gas, so in the bases you can remember by a trick, banana, it gives a yellow color. Okay, banana is yellow in color, so B for bases. So in bases we would be getting a yellow color for methyl orange. And litmus, can you tell me the color of litmus? Red litmus turns blue in the bases, right? Red litmus is gonna turn blue. Red litmus turns blue in the bases. So that is the color change we would be getting in the indicators. The next is reaction with the acids. Now we can say over here, ammonia is a weak base, okay, and it has tendency to accept the proton. So this is another definition of bases. How can we define them? They are proton acceptors. Now proton, we are talking about H plus ion. Bases accept the H plus ions. So ammonia has this tendency, like from HCl the H plus ion is coming, so ammonia is gonna accept it. So you know how it is formed, by a coordinate bond. We would be getting ammonium ion and chloride ion over there. So this is how ammonium chloride is having all the covalent bonds. How covalent bonds? In ammonia we have nitrogen hydrogen covalent bond, then one H plus ion, it binds with the coordinate bond, and chloride ion via an ionic bond. So covalent, coordinate and ionic. Okay, so similarly in the next one, in the reaction, it reacts with the acids to form the ammonium salts. Okay, simple easy peasy reaction. Reaction with the acids, ammonium chloride is a very good example where two colorless gases. Now we can talk about ammonia gas, you can take, and HCl gas are gonna give us ammonium chloride, a white solid that we would be getting. A very nice reaction where two gases are leading to the formation of a solid. Okay, so two colorless gases, ammonia and HCl, they are reacting to form a white solid. We are talking about ammonium chloride. You can see over here white fumes are also obtained. Okay, the next is reaction with the soluble metal salts. Now this is where we use in the analysis, qualitative analysis we have done, and यही आपने किया था with NaOH, and we can also have a weak base like ammonium hydroxide. So ammonium hydroxide, it reacts with soluble salts of metals, like we have taken ferrous sulfate over here to give the insoluble precipitates of the metallic hydroxide. So we can reach to the metal ion that was present in the salt of the metal. So we can reach to this iron. So you can see iron in +2 state is present over here, and by observing the color change of the metal hydroxide precipitate, like in this case it would be a dirty green color, so we can understand what metal ion was present in the qualitative analysis by noting down the color of the metal hydroxides. Easy. The next is reaction with the oxygen. Now talking about ammonia, it is not a supporter of combustion, not gonna burn in the presence of like oxygen may, no combustion would be shown. Okay, it extinguishes a burning splint because it is not supporting the combustion. So if you take a burning splinter and in the presence of ammonia, the flame would be extinguished and it is not burned in the air. But at the same time it can burn in oxygen, okay, and it will burn to give us a yellowish green flame that you can see over here. And because the driving force of the reaction is the affinity of hydrogen for oxygen, hydrogen and oxygen have very strong affinity for each other to bind with each other, so ekdam se the water formation is favored in the reaction and we would be getting a yellowish green flame in the reaction. Now this is an explosive reaction, it is dangerous, so we have to be very much careful because ammonia we are mixing with oxygen, so this requires risk. Now on the same go, we are having the next reaction, catalytic oxidation of ammonia. This is asked a lot number of time in exam, you have to be ready with it. Okay, in the presence of platinum. Why? Because the reaction of ammonia oxygen is anyway explosive also and it is not easily favored, so we have to take a high temperature condition in the presence of a catalyst, like we are taking platinum at 800 degrees Celsius. So what would be having, again hydrogen has a very strong affinity for oxygen, would be making water, and apart from that we would be getting oxide of nitrogen. Now what oxide is obtained, that depends on the reaction condition. Okay, so here we are getting getting nitric oxide and water vapor. Now this nitric oxide further reacts with oxygen and releases the brown fumes of nitrogen dioxide. So guys, I can understand there are a lot of reactions. You would be getting confused ki ma'am, so many reactions, but these are just 2-3 chapters chotu in which you have quite repetitive things. Okay, so just the observations you have to see very carefully, and if you revise them, then the reactions are not very much. You people have done qualitative analysis, so I believe that if a person can do qualitative analysis, they can do anything in their life. Okay, just a little more practice is required. Okay, can you tell me what ammonia is behaving as in this reaction? Is it acting as a reducing agent? Yes, reducing agent are the substances which help the other species to get reduced. So if you pay attention over here, oxygen has been added with hydrogen. So that means it is reduced and they are themselves oxidized. Reducing agent reduce the other species and they are themselves oxidized. So you can see over here in the reaction, ammonia is converted to NO, addition of oxygen. The reaction with carbon dioxide, so ammonia can react with carbon dioxide, not at a normal condition, 150 degrees Celsius and a high pressure like 150 atmosphere, to give us urea, which is a very good nitrogenous fertilizers. Okay, that is important for the farmers. Now another amazing important reaction is ammonia as a reducing agent. Very important. So ammonia, abhi bataya ma'am ne, it has a very nice property to behave as reducing agent. Again I am mentioning it, reducing agent helps the other species to get reduced and they are themselves what? Oxidized. So pay attention, this reaction can take place in two ways. The one, when one of the reactant ammonia is taken in excess. So how do we carry out the reaction? Ammonia is treated with chlorine. Now what happens here? 2 nitrogen, they releases nitrogen gas over here and 6 hydrogen combined with 6 chlorine and give you 6 HCl. Now this HCl is further reacted with ammonia. Okay, so what we are doing, we are converting all of the chlorine into hydrogen chloride first, then that hydrogen chloride is used to further react with ammonia and then we are getting ammonium chloride. There is no other option. Yahan par dekho, 3 hydrogen, 1 nitrogen, they take up 1 hydrogen, we get ammonium ion and chloride. Okay, so overall reaction, what you can write, dekho, this 6 HCl is common. We can cancel it. So the reaction is 8 moles of ammonia. Axis mein is reacting with 3 moles of chlorine to give us nitrogen and ammonium chloride. Okay, so what will happen here? The yellow color of the chlorine disappears and white fumes of ammonium chloride are formed because of this. So this is an important observation, and reactions observations are quite important. So pay attention to them closely. The next way the reaction can take place is when you are taking another reactant in axis, that is chlorine. So in that case, dekho, 1:3 ratio mein we have taken them, and here the reaction we are gonna get hydrogen chloride and nitrogen reacts with 3 chlorine atom, it combines and make nitrogen trichloride. This is again explosive reaction. We have to be careful while doing this. So theoretically you feel, ma'am, the reactions are difficult. Think what happens when they do it in chemistry lab. Okay, these reactions are showing us that chlorine has a great affinity for hydrogen. Yes, chlorine is taking away hydrogen, just like hydrogen and oxygen were having affinity for each other. We conclude that chlorine and hydrogen also have a lot of affinity, that they are making HCl very quickly, isn't it? Yahan par bhi we got ammonium chloride and nitrogen was sent just away separately, and ammonia is a reducing agent. These reactions are also telling us. So you can see over here, chlorine mein we are adding hydrogen. Other species is reduced by ammonia. Okay, and it is losing its hydrogen. So what it is doing? It is doing self oxidation. Right, so this is how you can see these reactions. Chlorine is added with hydrogen, that is reduction. So chlorine is reduced by ammonia, it acts as a reducing agent, and it is itself getting rid of the hydrogen. It means it is itself getting oxidized and reducing the other species. So acting as a reducing agent. Easy peasy. Another reaction where we can confirm it acts as a very good reducing agent by reduction of the metal oxide. So you can take copper oxide in the presence of ammonia. So you can see over here copper oxide lost its oxygen and getting reduced. And hydrogen took away oxygen, formed water, and now nitrogen is left all alone. Loss of hydrogen means oxidation. So it is itself oxidized, reducing the other species, acting as a reducing agent. Easy hai? Again with lead oxide, you can see lead oxide is a yellow color solid in the presence of ammonia. So what we are getting? It is losing, lead oxide loses its oxygen because that oxygen is taken away by hydrogen to make water. So we are getting reduction of lead oxide and ammonia is oxidized to give us nitrogen. Easy peasy reactions hai, dekh sakte ho dhyan se, you can wash them the either way. Okay, how this metal oxide is getting reduced in both the cases, hai na? Okay, the next one, how do we test ammonia gas and ammonium ion? This is something I want in the comment section for you to answer. Okay, easy hai bahut. There are few tests. Dekho, all ammonium salts generally produce ammonia gas when alkali like sodium hydroxide is added to them. So we have already seen this reaction. You remember just starting mein kiya tha, ma'am told you ki not all of the ammonium salts are gonna do this reaction. Remember, ma'am told you? Can you write the reaction for it? And which ammonium salts do not produce ammonia? The nitrites and the nitrates. Remember, ammonium nitrate is explosive. That's not gonna give us ammonia gas on the decomposition. But majority of the ammonium salt, just we can take ammonium chloride in the presence of NaOH, alkali, they are gonna give us what? Simple reaction hai, exchange the ions, salt and ammonium hydroxide will break to give us ammonia and water. Kar sakte ho, easy peasy ammonia gas we are getting. Okay, and how can we recognize it? Because it has a pungent smell. It turns moist red litmus paper blue. Some indicators, phenolphthalein pink and turmeric paper would be turned reddish brown. Okay. It can also be characterized by another test. It gives dense white fumes with concentrated hydrochloric acid. Can you write the reaction for this? Those dense white fumes are of what? Ammonia you are treating with dense. You have taken concentrated hydrochloric acid. Ammonium chloride ke dense fumes we would be getting, isn't it? Okay, so we can recognize that way. Okay, apart from that, see, I have this important one test again. Ammonia gas can easily be recognized by this test number 4. At first it forms blue precipitate with copper sulfate solution. Copper sulfate solution, when we are treating with ammonium hydroxide, this gives us copper hydroxide के what color के precipitates? Blue color. Okay, and the reaction is not over. When you are taking excess of ammonium hydroxide, then we would be getting a complex also. Okay, you can see over here it forms deep, intense, deep blue color. Okay, complex would be formed. So it dissolves to form a deep blue colored solution on adding excess of ammonia solution. कर सकते हो easy. This is that deep color that we are talking about because of the complex formation. Okay, so is there any other test for confirming the ammonia gas? Let me know. Okay, and mention the favorable conditions for manufacture of ammonia by Haber's process, although I have covered this already in the content. So just watch it out and tell me in the comment section what is the right answer, and do let me know if there is any confusion. I will be coming up with the Menti session separately. So just be ready with your content. And if there is any doubt, then let me know. Okay. And you can come in Vedantu subscription by using ma'am's code, that is SKA Pro. I'll see you in the next session, guys. And please stay hydrated and do not take stress. We can do this. Okay. Bye-bye.